So good morning to you all. Am I audible to you all, beta?
Yes, sir.
Hello, am I audible to you all?
Yes, sir.
Okay. तो कल हम लोगों ने जो पढ़ा था वो यहीं तक पढ़ा था हमने डिजिटल फ्रीक्वेंसी मीटर के बारे में वी स्टडीड एंड वी स्टडीड अबाउट दी हाई फ्रीक्वेंसी मेजरमेंट कि भाई ज्यादा जो हाई फ्रीक्वेंसीज होती है गीगाहर्ट्ज में जो रेंज होती है तो उसको मेजर करने के लिए हमारे पास में डिफरेंट टेक्निक्स हम अलाउ करते हैं तो वो ऑल दी 4-5 टेक्निक्स वी डिस्कस्ड इन दैट वाज द प्री स्केलिंग, that is heterodyne converters, transfer oscillators, automatic divider. These techniques we discussed, right? So today we are going to discuss about the digital measurement of time. कि जो टाइम पीरियड है उसको कैसे मेजर करते हैं, जो भी अगर हमें काउंटर का जो टाइम है कि भाई कितने टाइम के लिए वो पल्स जनरेट करनी है तो टाइम इज मेजर्ड. So that is the principle of operation of digital measurement of time is basically given as the beginning of the time period is the start pulse originating from input 1. जो भी हमें टाइम जहां से भी मेजर करना है तो वो स्टार्ट पल्स हमें जनरेट करनी है तो स्टार्ट पल्स से ही हमारा टाइम मेजरमेंट शुरू होता है. So beginning of the time period is the start pulse originating from input 1 and the end of the time period is stop pulse coming from the input 2. सर्किट देखेंगे हम यहाँ पे. तो जब भी हमारा टाइम पीरियड स्टार्ट करना है, टाइम मेजरमेंट स्टार्ट करना है तो उसके लिए जो है स्टार्ट पल्स जनरेट होगी इनपुट 1 से, तब से टाइम मेजरमेंट शुरू हो जाएगा और एक इनपुट 2 से स्टॉप पल्स इनिशिएट होगी. वो जब वो स्टॉप पल्स आएगी तो वहां तक टाइम मेजरमेंट हमारा रहेगा, फिर टाइम मेजरमेंट स्टॉप हो जाएगा. तो दिस इज द प्रिंसिपल वी आर फॉलोइंग इन दिस. क्योंकि टाइम मेजरमेंट अगर हमें करना है तो हमें दो कट ऑफ तो चाहिए ही चाहिए, है ना, स्टार्ट एंड स्टॉप. So the oscillator runs continuously, but the oscillator pulses reach the output only during the period when the control flip-flop is in the one state. That is true. पिछली slides में हमने पढ़ा था. The number of the output pulses counted is a measure of the time period. तो जितना हमने output pulses हम measure कर रहे थे, वही उसको time period को बता रहा था in terms of the frequency measurement. जो हमने पिछले जो PPTs में पिछले slides में हमने पढ़ा था diagram. So this is your time based selector basically कि how we are time based जो select करते हैं कि how we are measuring the time. So this is the time based selector circuit. We are using basically 1 megahertz crystal oscillator. The purpose of this crystal oscillator is to generate the frequency of 1 megahertz, constant frequency 1 megahertz with constant amplitude. Fixed generate करता है और crystal we are using as an oscillator and these are given to the Schmitt trigger. Now the Schmitt trigger is again converting this sinusoidal waveform into the square waveform. That is the main purpose of the Schmitt trigger. Then these square waveform are basically given to the divider, time-based selectors, the time period divider, right? So it is first divided by 10, again divided by 10, again divided by 10, again divided by 10, and there is some selector switch is there. So wherever the selector switch is connected to the position, तो वही division formula उसमें लग जाता है. So that give the time period of 1 microsecond, 10 microsecond, 100 microsecond like that. So it is clear that in order to know the value of frequency of the input signal, the time interval between the start and stop of the gate must be accurately known. ये बिल्कुल करेक्ट बात है. अगर मुझे स्टार्ट और स्टॉप पल्स का जो टाइम इंटरवल मुझे करेक्टली और एक्यूरेटली पता होना चाहिए, तभी मैं जो है उसकी फ्रीक्वेंसी को कैलकुलेट कर सकता हूँ. So this is called time base, right? So this is called time base basically. So the time base consists of a fixed frequency crystal oscillator called the clock oscillator, that is 1 megahertz crystal oscillator, which has to be very accurate. अब क्योंकि क्रिस्टल हमने यूज किया है तो क्रिस्टल की एक्यूरेसी 0.0001 ppm होती है, पार्ट्स पर मिलियन. तो इतनी बेटर एक्यूरेसी है उसकी क्रिस्टल की, तो इसीलिए हम क्रिस्टल ऑसिलेटर वी आर यूजिंग basically. So in order to ensure the accuracy, the crystal is enclosed in a constant temperature oven. अब क्रिस्टल के ऊपर एनवायरमेंटल कंडीशंस का इफेक्ट बहुत पड़ता है, तो उसको हम उसको एनक्लोज कर लेते हैं एक ओवन के अंदर में और एक केस के अंदर में, ताकि उसके ऊपर एनवायरमेंटल कंडीशंस का इफेक्ट ना पड़े। The output of this constant frequency oscillator is fed to the Schmitt trigger, which convert the input sine wave to the output, consisting of the train of pulses at a rate equal to the frequency of the clock oscillator. तो ये जो pulses Schmitt trigger ने generate की है, that is basically the rate of this, the frequency of these pulses is same as the frequency of the clock oscillator. Same frequency से ये square pulses generate होती हैं. So the train of pulses then passes through a series of frequency. The train of pulses then passes through a series of frequency divider decade assemblies connected in cascade, right? जो frequency divider circuit से pass होता है. Each decade divider consists of a decade counter and divides the frequency by 10. ये जैसा फिगर में visible है, उसमें आप देख सकते हैं. The output are taken from each decade frequency divider by means of the selector switch. Any output may be selected. That is very correct from the figure. So the circuit of figure consists of a clock oscillator having a 1 megahertz frequency. The output of the Schmitt trigger is 10 to the power 6 pulses per second. देखिए जब 1 मेगाहर्ट्ज फ्रीक्वेंसी है तो उसका क्या मतलब हो गया? 1 मतलब हो गया 10 to the power 6 फ्रीक्वेंसी. तो Schmitt trigger की भी फ्रीक्वेंसी सेम रहेगी 10 to the power 6 pulses per second, which is the frequency. And this point corresponds to the time of 1 microsecond. और इसको 1 microsecond टाइम पीरियड कितना होगा? 1 मेगाहर्ट्ज फ्रीक्वेंसी का टाइम पीरियड कितना होगा? 1 microsecond. Hence, by using a 6 decade frequency divider, यहाँ पे हम 6 decade frequency divider है, because जो frequency divider है यहाँ पे हम 6 यूज कर रहे हैं, इसीलिए इसको 6 बोलेंगे और decade बोलेंगे क्योंकि every time it is divided by 10, इसीलिए इसको decade बोलेंगे. So hence by using a 6 decade frequency divider, the time base with a range of 1 microsecond to 10 microsecond to 100 microsecond, 1 millisecond, 10 millisecond, 100 millisecond to 1 second can be selected using a selector switch. से हम select कर सकते हैं. So in some cases, just you see the diagram here, this the change in the diagram. Here there are two inputs we have used. As I told you in the first slide, there are two input 1 and input 2. Input 1 decide the start pulse and input 2 decide the stop pulse. तो ये start pulse होती है और input 2 होती है stop pulse. And there is a time-based selector switch, also time-based selector circuit, that is crystal megahertz, 1 megahertz crystal oscillator, Schmitt trigger, and this is the another circuit. So the measurement of the time period measurement is given in this block diagram. You can very well see this. When the input 1 comes, it is applied to the attenuator and amplifier, where it is condensed सिग्नल को जो है कंडेंसेशन के लिए भेज देते हैं, जहाँ पे उसका एज पर द रिक्वायरमेंट या तो उसको अटेन्यूएट करते हैं अगर एम्पलीट्यूड इज हायर, और इफ इट इज लेस देन वी कैन यूज एम्पलीफायर आल्सो. So input 1 and 2 both are given to the circuit, applied to the circuit where it is conditioning is done, either attenuation or amplification is done. दोनों में से एक करते हैं. Then both the inputs are basically separately applied to the Schmitt trigger, and Schmitt trigger then convert these input 1 and 2, which is sinusoidal waveform, convert into a square waveform. Schmitt trigger 1 and Schmitt trigger 2 both are we are using, and the output of first Schmitt trigger is basically start pulse, and the output of the second Schmitt trigger is the stop pulse, and both are given to the gate control flip flop. तो यहाँ पे हम SR flip flop we are using, they apply कर देते हैं start and stop pulse दोनों को RS flip flop में we are applying. Okay, and then the output of the flip flop which is Y and Y bar. तो यहाँ पे Y output जो है, अगर हम RS flip flop में input दे रहे हैं, R is the start is given to the R and the stop is given to the S, then Y output we are taking from the gate control flip flop, and the Y output is applied to the AND gate, one of the input of AND gate. Okay, और अगर ये 1 है that is the start pulse और stop pulse, तो ये अगर start pulse में अगर है output तो ये 1 हो जाएगा AND gate का एक input, और second input is coming from the crystal oscillator, वहां से शिमी ट्रिगर एंड देन इट इज गिवन टू द सेकंड इनपुट ऑफ द एंड गेट। तो जैसे ही सेकंड इनपुट एंड गेट पे आएगा तो ये फर्स्ट स्टार्ट पल्स को पास कर देगा एंड गेट एंड डेसिमल काउंटर एंड डिस्प्ले यूनिट डिस्प्ले। और जैसे ही वहां पे स्टॉप पल्स आएगा यहाँ पे एंड गेट के इनपुट पे, और तो आउटपुट हमारा स्टॉप हो जाएगा, जीरो हो जाएगा। तो दैट इज द टाइम वेयर दैट काउंटर विल काउंट। So just you see in the text, in some cases it is necessary to measure the time period rather than the frequency. Yes, कुछ केस ऐसे होते हैं जहाँ टाइम पीरियड की जरूरत होती है मेजरमेंट में, rather than frequency की जरूरत कम पड़ती है. So this is especially true in the measurement of frequency in low frequency range के cases में हम लोग time period measure करते हैं generally low frequency cases range. Now to obtain the good accuracy at low frequency, we should take measurement of the period rather than make direct frequency measurement. Correct. So the circuit used for measuring the frequency can be used for the measurement of the time period if the counted signal and gating signals are interchanged. So this is the beauty of this circuit. कि अगर counted signal and gating signals को अगर interchange कर दें, same circuit जो frequency measurement के लिए used for the time period measurement. So in the next slide, it is shown that figure shows the circuit for measurement of time period. The gating signal is derived from the unknown input signal. Okay, gated signal is basically derived from the unknown input. Is derived from the unknown input signal, which now controls the enabling and disabling of the main gate. The number of the pulses which occur during one period of the unknown signals are counted and displayed by the decade counter assemblies. And the only disadvantage is that for measuring the frequency in the frequency range, the operator has to calculate the frequency from the time by using the equation that is frequency is equal to 1 by time period t. तो यहाँ जो unknown frequency है वो है input 1 and input 2 basically, जिसको हमें time period measure करना है कि भाई ये कितना time period है इस frequency का. तो तो ये हमारी गेटेड पल्स भी कहलाती है बिकॉज ये एंड गेट के वन इनपुट पे अप्लाई होता है. ये पल्स जो कि गेट कंट्रोलर फ्लिप फ्लॉप का आउटपुट है. ओके, तो एंड गेट के एक इनपुट पे दिया जाता है. This circuit, this is the the way we are calculating. Now next is your that is the universal counter, right? So here in this universal counter basically we can study the universal counter. इसके अंदर universal counter के अंदर you can see there is again that is input 1 and input 2, and the same circuit we are using attenuator and preamplifier, then shimmy trigger. We are using the same circuit, and after that it is given to the logic control circuitry, means यहाँ पे logic control circuitry को दिया जाता है, and then after that it is given to the one of the output multiplexer. Maybe we are using here logic control circuitry में, because we are getting 3 inputs and we are getting some controlled inputs also. So one of the output of the logic control circuitry is given to the AND gate, and the another 2 output of the logic control circuitry is given to the controlled gate control flip flop, and the output of this controlled gate control flip flop is given to the another input of AND gate, and then it is being displayed by the displayer. Okay. Now the same circuit at the bottom we are using 1 megahertz crystal oscillator, shimmy trigger, then the time base selector switch and divider, time base divider, and then you can see that is the time interval, ratio, external standard control voltage, time period. There are various selection positions which you can select by a selector switch. So the all measurements of time period and the frequency by various circuits. तो universal counter का purpose यही हो गया कि universal नाम जैसे डला हुआ है, तो universal means it can do all the things. The same meter can be used for the all purposes. Means it can measure the frequency, it can measure the time period, time intervals, time periods, and the ratio, like that many things it can measure. That's why the name is given as the universal counter. So the all measurements of time period and frequencies by various circuits can be assembled together to form one complete block called the universal counter timer. The universal counter basically uses the logic gates which are selected and controlled by a single front panel switch known as the functional switch, that is the function switch. Okay, so the simplified block diagram already shown above. With the function switch in the frequency mode, a controlled voltage is applied to the specific logic gate circuitry. यहाँ पे उसके through the selector switch के through a control voltage is selected, and as the input signal is connected to the counted signal channel of the main gate. So the selected output from the time-based divider is basically simultaneously gated. Selected output from the time-based divider, जो time-based divider से जो भी हम output जो select करेंगे, जो signal select करेंगे, उसको simultaneously gated to the control flip-flop. वो साथ में control flip-flop को दी जाती है, which enables or disables the main gate. Both control paths are latched internally to allow them to operate only in the proper sequence. When the function switch is on the period mode, right? अगर function switch को आप period mode में रखते हो, the control voltage is connected to proper gates of logic circuitry, which connects the time-based signal to the counted signal channel of the main gate. Correct. At the same time, the logic circuitry connects the input to the gate control to enable or disabling the main gate. So very clearly and बहुत ही precise manner में और बहुत ही best तरीके से ये the things have been explained here in this paragraph. बहुत ही simplified way में कि how the signal is connected to the various circuits. Next, in the same pattern, we can design the decade counter. Same pattern पे जैसे universal counter हमने design किया, in the same pattern we can design the decade counter basically here. So as you can see in this decade counter, we are using the 4 flip-flops. We are using here SR flip-flops, and the one AND gate we are using here. So a decade counter is a circuit of flip-flops in cascade which counts in sequence 10. Counts in the base 10 decimal number system. The decimal number system में count करेगा ये, and this means that there is a sequence of 10 distinct count in increasing orders. जैसे 1, 2, 3, 4, 5, 6, 7, 8, 9 from 0 to 9. So the 3 flip-flop cascade progress through 8 distinct count. Right. तो यहाँ जो 3 flip-flops हमने जो use किए हैं, तो 3 flip-flops in cascade progress through 8 different counts. The binary numbers from the 0, 0, 0 to 1, 1, 1, 1, 1. तो ये आपने जो काउंट करेंगे यहाँ पे, ये काउंट कहाँ से कहाँ तक हो जाएगा, 0, 0 से लेकर के 7 तक काउंट होगा, 0 to 7. और अगर we are using the 4th flip-flop, it can count up to 0 to 15, right? तो total 16 position we can count. While the 4th flip-flop in the cascade progress through 16 different distinct states, the binary number from 0000 to 1111 means 0 to 15. So hence to get a count of 10, तो अब अगर मुझे count 10 count, excuse me, अगर मुझे 10 count लेना है तो कितने flip flop यूज करना पड़ेगा? Definitely I have to use 4. 3 से मेरा काम नहीं चलेगा क्योंकि 3 से तो मेरे को 8 तक ही डिजिट तक नंबर मिलेगा, 0 to 7. और अगर मुझे 10 count करना है तो I have to use the 4 flip flop. I have used the minimum of the 4 flip flops are required because the 8 distinct states are less, while 16s are too many of the decade counter. So this problem can be overcome by using the 4 flip-flops in cascade and resetting the output of each flip-flop to 0. तो यहाँ पे क्योंकि ये flip-flop में चारों, ये तो 15 तक काउंटिंग करेंगे 0 to 15, तो हमें इसको डिजाइन करना पड़ेगा इस तरीके से कि जैसे ही मेरी काउंटिंग 10 तक जाए तो उसके बाद में मेरे सारे flip-flop रीसेट हो जाएं 0, 0, 0 पोजीशन पे. So this problem can be overcome by using the 4 flip-flop in cascade and resetting the output of each flip-flop to 0 after desired 10 counts. So this figure shows the decade counter using the 4 negative S-triggered flip-flops in cascade. So just to see the pulses, from the pulses you can very well simulate the results here, and you know the function of the each flip-flops. So when the pulse trains, you just see that when the first pulse trains comes, when the wave becomes a high, जो पहला जो pulse train आती है, that is the वो high होती है, जो clock की हम बात कर रहे हैं. So when it is the high, तो output A, you can see output A, B, C and D. So when it is high, the output of this the first flip flop, the A becomes low. तो वो आपका लो है यहाँ पे. देखिएगा जब यहाँ पे हमारी जब इसमें हमारा जो पल्स ट्रेन वहां से जो ऊपर से टॉप, द पल्स ट्रेन इज कमिंग फ्रॉम द टॉप, और राइट. So you can see the pulse train, which is the clock pulse. You can see the pulse train, which is the clock pulse. When it is applied, the clock pulse is applied. So already जो ऊपर जो है वो already this is connected to the high, plus VCC पे connected है top वाला. So when the clock pulse comes here, तो clock pulse में 0 1 0 1 0 1 0 1 आप apply करेंगे, और S is already you can see the output of S. थोड़ा सा circuits में misprint हो गया, तो just you see it, इसको misprint को आप थोड़ा चेक कर लीजिएगा. यहाँ पे basically the output of the AND gate is connected to the R, and the high from the top is connected to the S. तो यहाँ पे एक्चुअल में VCC जो कनेक्टेड है वो सभी S पे कनेक्टेड है, और आउटपुट ऑफ जो एंड गेट है वो R पे कनेक्टेड है सभी पे. तो दैट यू कैन सी, थोड़ा सा ये सर्किट में डिजाइनिंग में थोड़ा सा पार्ट है, एंड क्लॉक is connected to the first flip flop, right? So when the pulse train is coming, or S is a high, and you can say VCC high, and the output of the AND gate is connected to the R. So what the first we are assuming, when the clock is high, the output of A is 0, output of B is 0, C is 0, and D is 0. Now when the clock changes from the high to low, जब यहाँ पे मेरी क्लॉक का ट्रांजिशन होता है, because these are the negative edge triggers we told, these flip flops are the negative edge triggers. तो negative edge triggers means जब rising part होता है क्लॉक का, that is called positive edge, and when the falling edge होता है क्लॉक का, that is called negative edge. तो यहाँ जो भी ट्रांजिशंस होंगे वो नेगेटिव एज ट्रिगर्ड होंगे, यानी राइजिंग पर जब क्लॉक हाई होने जा रही है तब नहीं होगा ट्रांजिशन. ट्रांजिशन तब होगा जब आपका क्लॉक हाई से लो की तरफ जाएगी. दैट्स व्हाई इट इज नोन एज अ नेगेटिव एज ट्रिगर्ड. So when the clock is going from the high to low, that is a negative trigger. तो उस टाइम पे the state, whatever state is there at the S, is being reflected to the A. तो वो A पे reflect हो जाता है, and the A becomes high. तो यहाँ पे वो A high हो जाता है. Now the output of this, the output of the A यहाँ पे अभी connect नहीं किया गया है. That is basically there is a problem in this the circuit में, आप देख लीजिएगा. The output of A is taken outside. तो जो A का जो आउटपुट है उसको हमने बाहर ले लिया है, एंड साइमल्टेनियसली द आउटपुट ऑफ A जो A है, द फर्स्ट फ्लिप फ्लॉप का जो आउटपुट है, दैट बिकम्स द क्लॉक फॉर द सेकंड फ्लिप फ्लॉप. तो ये दो चीजें हो जाती हैं कि जो आउटपुट जो फर्स्ट फ्लिप फ्लॉप का जो आउटपुट है, दैट इज A, becomes the clock for the second flip flop, and A जो आउटपुट है वो आउटपुट भी लेते हैं. So A becomes the high now. Now when the A becomes high, तो ये नेगेटिव से पॉजिटिव चला गया, तो सेकंड फ्लिप फ्लॉप ये पॉजिटिव एज ट्रिगर्ड हो गया, तो ये रिएक्ट नहीं करेगा. ये रिएक्ट तभी करेगा जब नेगेटिव एज ट्रिगर्ड होगा, यानी कि जब A का जो आउटपुट है, और जो फर्स्ट फ्लिप फ्लॉप का जो आउटपुट है A, जब वो हाई से लो होगा, तभी मेरा सेकंड फ्लिप फ्लॉप मेरा आउटपुट जनरेट करेगा. तो यू कैन सी in the second clock, when the negative edge trigger comes in the second clock, the output A transit from the high to low. When it transit from high to low, then it activates the second flip flop. तो second flip flop भी मेरा output high हो जाता है, B high हो जाता है उस टाइम पे, और ये मेरा high रहता है. And simultaneously you can see the output A will basically will toggle at the second clock, the transition of the second clock, as negative as triggered of the second clock, पे toggle करेगा output A, while the output B will toggle at the second and the fourth clock. Second and the fourth clock, or you can see of the train pulse, and similarly the output C, and similarly the output D. तो यहाँ आप इसको रिलेट कर सकते हैं. तो प्लीज कोरिलेट दिस, तो पता चल जाएगा. यहाँ पे थोड़ा सर्किट में थोड़ा डिसकंटिन्यूटी है, वो मैंने आपसे अभी डिस्कस कर लिया है, तो उसको डिसकंटिन्यूटी को आप करेक्ट कर लीजिएगा. राइट. The same thing has been cleared here also. So the electronic counter, basically the decade counter can easily be incorporated in a commercial test equipment instrument called the electronic counter. A decade counter by itself behaves as a totalizer by totaling the pulses applied to it during the time interval that a gate pulse is present. तो basically electronic counter में क्या करेगा, वो जो total pulses को count करेगा, जितनी pulses वहाँ पे आपके वहाँ पे appear हुई हैं. So decade counter will count the total the 10 pulses basically. So this mode of the operation are the totalizing and the frequency, totalizing frequency, period, ratio, time and interval and averaging. So just to see the totalizing, how the totalizing is working here. So you see that the basic principle is shown here in this diagram. So input of the AND gate and the second input is given through the power supply. Okay, power supply E and it is connected through some switch. तो जब स्विच ऑन होगा तो पावर सप्लाई हाई कनेक्ट हो जाएगा तुम्हारे एक एंड गेट के एक इनपुट पे. तो जो भी मेरा इनपुट सिग्नल पे जो भी अप्लाई होगा वो सेम थिंग विल बी रिफ्लेक्टेड एट द आउटपुट ऑफ द एंड गेट and same thing will be given to the decade counter and the overflow indicator will indicate. So in the totalizing mode as shown in the figure above, the input pulses, तो टोटलाइजिंग का मतलब है कि जब तक मेरा स्विच ऑन रहेगा, मेरी पावर सप्लाई ऑन रहेगी, तब तक जो है मेरा जो भी इनपुट पे पल्सेस आएंगी वो सारी की सारी मेरी जो है वो मेरे गेट एंड गेट के आउटपुट को रिफ्लेक्ट करेंगी और वो सब मेरा काउंटर जो है मेरा उसको काउंट करेगा. तो जैसे ही मेरा जो पावर से जो सेकंड इनपुट एंड गेट का जो ई सप्लाई है पावर सप्लाई वो डिस्कनेक्ट हो जाएगी तो मेरी काउंटिंग स्टॉप हो जाएगी. Excuse me. In the totalizing mode as shown in the figure above, the input pulses are counted, totalized by the decade counter as long as the switch is closed. If the count pulses exceeds the capacity of the decade counter, the overflow indicator is activated and the counter starts continuing again. So that is very important. If the count pulses exceeds the capacity of the decade counter, ये अगर 10 से ज़्यादा हो जाता है decade counter की counting, तो overflow indicator is given here. तो वो overflow indicator जो है उसको indicate करना शुरू कर देगा कि आपका 10 counting पूरा हो चुका है, and this is activated and counter को reset कर देगा and counter will start continue again. So this is the next the frequency mode क्योंकि इसमें different mode है electronic counter में. So just totalizing, first we studied about the totalizing mode and next is your frequency mode. So if the time interval in which the pulses are being totalized is accurately told, the counter operates in the frequency mode, right? अब counter मेरा frequency mode में operate करेगा. The accurate control of the time interval is achieved by applying the rectangular pulses of known duration to the AND gate. जैसा फिगर में बताया था. So in place of the DC voltage source, this technique is referred to as the gating the counter. And the block diagram of electronic counter operating in the frequency mode is shown in figure. The frequency of the input signal is computed as f is equal to n by t, where n is the pulse counted कि कितनी pulse उसने count की है, number of pulses, and t is the duration of the gate pulse. तो जो मेरा gate pulse है means मेरा जो supply है वो जो switch कब on हुआ और कब off हुआ, that time duration is known as the t, duration of the gate pulse, and n is the pulse counted and f is the frequency of the input signal. Oh, next is your the ratio mode basically. So this is my the ratio mode. So in this ratio mode of operation, simply displays the numerical values of the ratio of the frequency of the two signals. तो दोनों frequencies का जो ratio है, उसका जो numerical values है, that will show in the ratio. So ratio mode of operation simply display the numerical value of the ratio of the frequencies, the ratio of the frequency.